going to talk about the sign of the quadratic. It's just a bit of terminology here. Positive definite. That's an example of a positive definite parabola. It gets its name because it does not matter what value of x you substitute in, you will get a positive answer for y. It's completely above the x-axis. So it's definitely going to give us a positive answer, hence the name positive definite. As well, what do we notice? It's concave up and there are no x-intercepts. So a would be greater than 0 and the discriminant would be less than 0. There's a matching one, negative definite, which is always below. That one is concave down with no solutions, so the discriminant would be less than 0. Then you've got all these other situations, which pretty much we just call one thing, indefinite. There's one that just touches, and there's ones that cut. But you can't definitely say they're positive or negative because there's some points when they're 0, some points when they're positive, some points when they're negative. Really, we just call them indefinite. And I suppose really the condition for that, when you look at the 4, it's got nothing to do with the concavity. It's just simply the discriminant is greater than or equal to 0. It has some solutions. So if we wanted to make this one positive definite, in other words, we want to make sure, well, it's an equation, it'll end up having no solutions, but if I was to substitute in for x, I'd always get a positive number. So first thing to check, well, the concavity's got to be greater than 0, so I know k has to be positive. And then discriminant has to be less than 0, so b squared minus 4ac, k squared is greater than 9, but both conditions must be satisfied. So therefore, k is greater than 3. So that was a nice quick one. There we go.